All right. Hello, everybody. Uh, Welcome to the Friday. Well, it's not Friday today. Today's Thursday, but due to scheduling reasons, I am shifting every other live stream to a Thursday. That's just to accommodate my work schedules. So I got my furlough. My job got furloughed, so that means that from now until the end of August, that um, every Friday I actually have off. So, and I go home back to Massachusetts every like 2 weeks. So, essentially, I'm just alternating um, each week. The weeks that I go back, I usually do a stream on Thursday, which is like today. Um, but yeah, so usually it's on Fridays, but because of this screwy schedule with the things that COVID has caused, um, it's gonna be alternating between Thursdays and Fridays every 2 weeks. So hope you guys understand that. And I guess with the schedules and whatnot out of the way, we can get started with today's session. I just want to really quick go over what we did last time um, in terms of rapid prototype 004 here. We basically integrated the entire fuselage. We attached the booms, um, and then we also kind of just right. We finished the fuselage molding, especially this area in the back. So it's kind of just like an overall integration kind of a build. And that's when things get really exciting because that's when you can really see it all come together. Um, but yeah, that was basically last week was just like finishing off the tail end of the fuselage here. Right, as you can see, the panels kind of align and fit together neatly. Um, so that's that happened, and also the twin booms were installed. I think I spent like a couple minutes like trying to figure out how to integrate this nicely and create a fairing, but I decided that that would have taken too much extra effort, and the payoff is not that much. Um, as you can see, this attachment right now is pretty strong. It's a tape, kind of just a lot of tape wrapped around this way first, across the straw to really secure it down. And then to secure the tape from ripping apart, we used tape in the longitudinal axis aligned with the aircraft axis to really tape the tape down, if that makes any sense. So we taped the straw down first and then used tape to secure the tape that was used to secure the straw. So it's a little bit meta there, but that was what was done instead of adding like a specific structure that would have taken like at least half an hour or an hour to really prototype and design. So this simplifies things. Hopefully it'll be durable enough during flight tests. We have yet to see that. So after the build last week, I didn't get to do this on the stream, but I did cut some control surfaces. Here you can see on the inboard of the spar, we have some flaps. So these are symmetric on both sides, and they act as kind of a, well, they're what flaps do, really. Um, they provide a lot of lift, and it slows down the aircraft. You can actually tell when you fly this thing, when you put the flaps down, it really slows down, and you can really feel it become more floaty. Um, if you have pitch trim up, so that means that this surface is folded up. That means that you're gonna want to pitch up like that, and so a little bit of pitch up combined with flaps down, you cancel out the moment, and you get a really floaty characteristic in the flight of this plane. And then outboard of the booms. My apologies. So the stream got interrupted. So whoever was on at the time, I apologize for that interruption. My phone overheated, and so that's kind of why the stream just got interrupted and stopped for a second there. But anyway, yeah, so I apologize in advance if that happens again. Literally, my only solution for this is to put my phone in the freezer for a couple seconds, maybe 30 seconds or so, and then take it out and then continue. So hopefully, this doesn't happen again, but I have a feeling it will. Today's a really hot day. It's like 80 something degrees, as you can see. It is almost 87 degrees outside, or it is exactly 87 degrees outside. So, yep. It's really hot. That's my point. It's really warm today. My phone overheated, and that's kind of why the stream was interrupted. So I apologize in advance again. If this happens again, just hold on tight. I'll try and get back to you as soon as I can. I literally just put my phone in the freezer and have it cool down rapidly, and then come back to the stream. So that's my solution for that. But anyways, yeah, we were talking about kind of what we did last week for Rapid Prototype 004. The plan this week isn't to really build anything for this project in particular. I will discuss kind of the modifications that I made. So after last week's stream, I made these control surfaces, right? So before the stream cut out, I was discussing how I made the flaps. I just kind of cut it inboard of the boom and then right at the root here of the structure. So outside of the wing guard, but at the root. And this serves to slow the aircraft down. And with a little bit of elevator up, it actually becomes really floaty and nice. You can really tell it's like at high lift, you can really feel it in the flight. Outboard of the boom, we have kind of full length ailerons. So these are actually not that great. So that's like one thing I don't really like about this prototype in particular is the wing is extremely warped, if you can tell from the back here, right? This edge isn't straight. And I have a feeling that's due to the fact that, the spar is so close to if you can see like a minor imprint here in the cardstock, the spar is so close to the leading edge and the trailing edge that it just kind of like warps the thicknesses, right? So it transitions really rapidly and you have this weird curve in the trailing edge. I'm sure like the cross section varies, and I'm not exactly sure how that affects the flight performance, but we will see. And that brings me to my next point, is that from preliminary kind of just flights indoors, it appears that this design has some issues with yaw stability. And to be honest, that's completely expected with a design like this, especially because this is like a novel configuration. This isn't like something that you see in real life planes, right? You've never seen really any plane in real life that has forward swept wings and twin boom. Like, so any like unstable performance characteristics can be kind of understandable, right? Because they don't use it in real life. There's probably a reason for that, and we're discovering that reason right now on our own. So yeah, from preliminary flight tests indoors, it has yaw issues, and I think that's greatly due to the fact that the A-tail is just so shallow. I mean, it's just like not enough vertical area. It's very sleek looking, which makes it nice for looks, I guess, but it doesn't have enough vertical, volume. If you ever took, in your space engineering class, you'll know that this, um, I guess, metric is called the, the tail volume ratio, where it's like your surface area times your distance from the aerodynamic center. It gets all complicated like that, and we're not going to get into the details of that here, but essentially, this is not enough area, right? This might be enough area if the booms were longer and it went further back, because that gives it more leverage, right? So that makes it more stable in the yaw direction. So yaw direction is, the aircraft going like this. Up and down, it seems all right, it seems stable in terms of that. But when I fly it, it kind of just tail spins out of control, and that's due to the fact that we don't have adequate yaw stability. And the way to fix that would be, in this case, either to extend the booms back, which is going to be difficult because this is really tightly integrated. So we either move it back or we increase the surface area here, which, to be honest, we're kind of in a bind here. We don't really have like a proper solution for either method, because this is just so integrated. So the only way to really fix this would be to uninstall the twin boom, remake the tail, which would take a lot of effort, or we can try and figure out something else. My initial idea for something else would be to really just force this tail to be up higher like that, and also add an additional third fin right in between. So that would be mounted on this tail structure here, somehow connecting to the top, and then mounting it higher. So basically, making the tail higher here, and also adding another vertical surface in the middle. Now, I have no idea if that'll work. I also think that's a lot of work, and it ruins the look of this prototype. So I really don't know. I might just have to come up with a solution in a future stream, because that wasn't the plan for this particular stream. This stream was planned for a new kind of build, which I'll get into in just a moment. But just wanted to give you guys an update on the rapid prototype 004. From the preliminary flight test indoors, we also found out that the winglets aren't that great for durability. Forward swept wings and downwards winglets, that's just like not great. Every time you crash, like your winglet is just gonna be destroyed, absolutely destroyed. So that's new learning. That's good to know, good to keep in mind for future designs. Yeah, with that said, I think we will put this project on the side for a bit, and I might do some modifications in a stream or just on my own time. And so you probably won't be able to, you'll definitely see the end result. It's just how I decide to fix this problem with the yaw stability is gonna be kind of up in the air. I might fix it off the live stream, or on, but we'll have to figure that out. Yeah, I wanted to get started today in this stream with a new build. And so this one has been in the making for a long time. I haven't actually made a video for this project. What I'm about to do is create a kind of realistic, based on real life model of the X-47B, which is the MQ-101 design in Ace Combat 7, if you ever play that game. That plane is one of my favorites. It's a UAV. It's a UCAV, so unmanned combat aerial vehicle. So UCAV basically. It's a great design. It's very simplistic. It's a flying wing, and I guess it's easier to just show you guys. So what I have right now is a piece of paper. Normally, at least with the rapid prototype, I designed the layout for this. But for the X47, there are plans already out there on the internet, so it actually makes no sense to just like try and draw that by hand and recreate the template. So we're gonna take advantage of technology, and this is the nice parts about having an iPad, especially one of the newer generations here, is that the screen is large enough to be kind of a light box. So this paper is just regular printer paper. It's very lightweight. You can probably see through it if you tried really hard. But basically, if there's a bright light behind this piece of paper, it's going to show, and you can actually trace shapes off of that. And so I want to introduce you to this neat workflow that I came up with. This is a nice part about having a powerful creative tool like the iPad, is that, I gotta unlock it first. Face is too far away. Ah! Alright, here we go. There we go. Alright, so it's unlocked. That's the YX10 Astra M1 variant, by the way. It's just a concept sketch. I am working on that. That's a prototype in a shoebox right below my desk. But yeah, we will get back to this in a future stream. I just wanted to get started on something new today, something that I know will definitely fly really well. So yeah, let's get started. What I have right here is a top view of the X47. This app is called Table Trace or Trace Table or something like that. And it was like $2, but it does one job really, really well, which is it displays an image and it locks it in place so you can't move it by accident, right? And so that's really helpful because if you're into creating things based off of, shapes like this, then it's really, if you trace shapes a lot on paper, and this app is actually really powerful for that purpose. So what we're gonna do today is kind of just create the templates. If you recall from my previous build here in the prototype 004, I made templates on printer paper before I transferred them to cardstock. So we're gonna do that again today, except with an existing design, so we don't actually have to design the actual layout. We don't have to worry about that at all. It is already done. So this should be a relatively quicker build than the design from scratch prototype 004. So what we're gonna do right now, we're just gonna get into it. I'm gonna create the templates here. So we're gonna start with, so as you can see, right now, if I touch the screen, it's not going to move because I locked it in place. This is the feature of the Trace Table app. It's really nice for that purpose. What you can do is you can align. Kudos to you. All right. Yeah, it's just not my day today. It's really warm and sorry about that. That was hectic. I dropped my phone too, so. All right. It's gonna overheat. It's only a matter of time. It's really hot outside today, so apologies in advance if it happens again. We'll get straight back into where we were at. So I'm just gonna let the camera focus a little bit. All right. Plug my phone in. All right, so as I was saying, we're trying to incorporate some new technology into our workflow. So right here we have a 2018 iPad Pro 12.9 inches diagonal. So this is actually perfect because it's about the size of a sheet of paper. If you look at this, it actually fits really nicely. And so we're able to use that advantage. And this new app that I mentioned, which is Trace Table, I did not develop it. They are not sponsoring this video. I am just using their app as a creative tool here. So we're going to use this as a light box to transfer our templates, which are predetermined by, you know, just this was from Wikipedia for the X47. So it's really easy to get these blueprints or drawings. And then we're just going to start tracing some of the shapes here. And actually, instead of tracing, it's actually easier to like draw the points, like where the vertices are. So like this point right here, this point right here, and because most of it is straight lines, if you trace out, you know, it actually takes effort, and you have to use your pencil with a ruler on top of your iPad, which is not great. I mean, it's designed for like a stylus, but like an actual 0.5 millimeter lead pencil is not a good idea to be like, you know, really drawing on your iPad. So what we're gonna do is we're gonna lightly mark the vertices, right? So that point right there, this point right here, this point, this point, this point, this point, this point, this point, and this point. And then we are gonna go from there, right? Once you have the points down, all you need is really to draw a line between them, and you have a straight line. So, and it's also important to note, I think in this particular build, I have this set at 6.5 inches from nose to tail, or at least it's pretty close to 6.5 inches. And that's gonna set our size, right? Because the shape is kind of locked in place, as long as you have the same measurement, you're gonna get a result that's very similar to mine if you choose to build this plane. But yeah, let's get started here. I'm just gonna zoom in a little bit, and we're gonna start with the fuselage here, and that's just to create a template. And the reason why we're not doing this directly on cardstock is that it's just not possible with cardstock. At least I don't think it is. We can actually try it right now, but I don't think it'll work. You know, cardstock is a thicker sheet material, so you won't be able to see the light through that. So you need to transfer the design onto material that you can actually work with, right? And that, in this case, is just regular printer paper. It's lightweight, it's versatile, it's cheap, it's very available. So we're gonna get started. I'm gonna align my paper edges to the iPad. Right? The iPad Pro 12.9 inch is perfectly designed to like replace your average 8.5 by 11 sheet of paper. Right, it actually works out really nice. The sheet of paper completely covers the iPad. So highly recommend it. It's a really great creative tool. So we're gonna start here. You can see that vertex, right? Just mark a light point there. Mark a point here, 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 right? It can get a little faint, so you have to really be good and diligent about eyeballing correctly. And then the tail here, tail end, right? And the right side, or left side, this plane. So we have our vertices marked. What I also like to do is mark where the control surfaces are. Just like, this is good for reference. So I like to do this, right? It's just for just good record keeping, I guess. And that's pretty much it. That's all we really need this iPad for. So now we have the information we need to start creating the templates that we will eventually create into cardstock parts. Right? This is really easy. This is like grade level easy. This is just connecting the dots here, right? So just, you know, take a straight edge, because this design is straight, you know, like a lot of the edges are straight. Just do that, right? And then let me just zoom out a little bit. If my phone overheats again, I apologize in advance. My only solution right now is to just throw it in my freezer and wait a couple seconds. So bear with me if the live stream gets interrupted and pauses or something. So yeah. All right, so we got the left side. Put this at the vertex here. Okay. Just draw that. Mark this, right? This is the wing root, right? And then this is the outboard wing on the starboard side. So that means right side. Starboard means right, which is aerospace lingo. So yeah, this point to this point. Right. Then this point to this point. Now this is one of the distinctive features about the X-47 is this winglet that like kind of tapers off into a point here. At first, I really didn't like this design choice. I was like kind of like just confused, like why you wouldn't just end it like a straight line here. But it turns out, for most stealth aircraft, you will actually want to have as many parallel edges as possible to reduce the radar cross-section, to reduce the RCS. So in the case of the X-47B, you might notice that this outboard wingtip line is parallel to kind of the main body here, right? This is like the fuselage, wing body, kind of leading edge here on the inboard, and you know it's parallel. So these two are parallel. So that's a nice, interesting detail about the X-47 that, you know, the more you learn about it, the more you can appreciate why, you know, it looked the way it did. It's not just to look different, you know, some of these things, they really do have functions behind them, right? And that's kind of when the best design occurs, is when you have a need for something and create a specific design for it that looks different because it has to function different. And that's when, you know, things get exciting in design. So right now I'm just tracing that, right? And then so we have the trailing edge here. I'm going to connect it to the middle here. This leads me to believe that the you know, the thing, use my words, the drawing that we referenced isn't actually very precise, because we know that in a stealth aircraft, the edges want to be parallel, and so this trailing edge here should be parallel with this edge. So I'm not sure why that is not the case here. Let me just double check with what was on the iPad real quick. So let me just lock this. All right. So if we look here, did we make a mistake, or are the drawings wrong? It looks like the drawings are wrong. So if you look at this edge right here, this ruler has parallel edges. So essentially what we're seeing is that this edge is not parallel. And so that means whoever made this drawing did it incorrectly, which is, to be honest, that's disappointing. But it is what it is. We might have to modify this. I don't know how I would modify it because the geometry is pretty constrained. If I shift this ruler to align itself with that tip, we're gonna increase the size of our design, of our footprint a little bit. This is like nitpicky. You don't really have to do this. It's about getting things right. There's something about getting things right. So I actually have like a previous prototype here that I conveniently forgot to show you guys. This prototype is kind of just crap. I didn't really do a good job of building this. As you can see, the wings are cantilevered, but they're not supported internally. And so what happens is it becomes really, really weak. So it's literally just this part folded in on itself, double layered, and then attached somehow to this, you know, and so it's not very nice. So we're trying to create like a better, slightly bigger version of this that has a new spar, a thinner spar, and hopefully that will be extremely aerodynamic and this thing will fly really nice. In my past experience, the X47 cannot fly by itself, but if you add vertical stabilizers like right about here, it becomes a really nice outdoors flyer. And just it's because of that flying wing configuration. It's super aerodynamic and efficient. So yeah, I'm not sure if I want to edit this or modify this. This is an interesting point. I feel like I feel conflicted right now, right? It looks parallel, but it is not. And it very well might be not parallel in real life, but I'd like to believe that the designers of this airplane kept it consistent. Yeah, this is not exactly parallel. So, all right, we're just gonna go with what we have. I don't want to spend too much time, designing the template from scratch again. One of the benefits about doing a real life design is that it's faster R&D and making compared to designing something from scratch. So we're just gonna go with it. We're just gonna chug through here. Yeah, we want to end this by closing off this edge here with this vertex to this vertex. So that's really easy, right? So now we have the shape on paper in a physical format. Of course, you can print it out, but in my new apartment here in Connecticut, I don't have a printer, and a nice printer would cost a lot of money. So I'm doing things this way. I'm gonna use what I have, which is an iPad, which is expensive in itself. So it's like, why don't you have a printer, But to be honest, I don't have a printer because it's not very useful to me. Other than this hobby, right? I don't print things on a day-to-day basis. It's just not how I do things. Most things are electronic these days, so that's just me. Anyway, so we have the plans down. So right now, I think I'm gonna cut this, right? So we definitely need a fuselage part. We also need the fuselage to be kind of double-sided, so double layered, I mean. So that means that we need a portion here that'll fold over and form a nice fuselage shape, right? So we're gonna do that. We're gonna cut this, right? This line, all the way here. So everything but this line, and then leave the wing alone for now. And then fold this shape over and then mark 2 points. So hopefully we get like a template shape. So you could totally actually do this in PowerPoint and then print it out in the end, but I don't have a printer again, so you gotta do what you gotta do, you know, with the things that you have. So to cut this, I'm going to call in a specialized tool. This is a cutting board by Fiskars. Again, not sponsored, just a good tool that I like to use. It's really great for cutting straight edges. So yeah, I am going to try and do this. This is kind of jank, to be honest. This is like not great because the paper's not lying flat completely, but I'm gonna make do here. So you line it with the wire. There's a wire in the middle. You can't see that. It's like a metal steel wire. So if you line that right on top of the edge you're about to cut, and you slide this through, you get a clean cut really fast. Sometimes for these shorter ones, I do like to use scissors, but since we're in this cutting board mode right now, we're just gonna go ahead and do it. Right, so that could have been done in 2 seconds by a pair of scissors, but then I would have had to switch tools and that would have taken longer. So let's see, just line this up. And then, hello again. I apologize for the interruption. That is my phone overheating again. This is the third time. And it's only gonna get worse throughout the summer, so I am very sorry. All right, I'll plug my phone in. I'm gonna keep on going where we left off. All right, so here is gonna be interesting, right? Because we don't want to cut the wing, but we also need to make the straight cut. So what I'm gonna do is gonna do a partial cut. Don't cut all the way. And we're gonna bring it close, right? And this is when knowing your tool will really help you, right? This thing right here, it cuts right to the midpoint right here. So you kind of just have to eyeball, like, okay, if I want to cut to this line, right, I just have to move the center all the way here and not go over, right? So it's a very like niche thing. It's a very detailed thing to know, but it's useful. And then we're gonna have to make this cut. This cut is gonna be kind of hard. I mean, I guess I could do it with a cutting board. Let's just try that, to be honest. I was gonna use my scissors, but for sake of consistency, I guess I will do this then. All right, that looks good. And then you just cut all the way here. And there you go. You're all set. I will cut the wing leading edge here at some point, but we need to prioritize the fuselage first because that's kind of the main part of the design. Yeah, so I'm gonna fold this across this line to get like that double layered layout. And the way I do that, again, this is similar to the technique used in the prototype 004. You use 2 rulers, one to lock the edge in place, right? And then the other to really just fold this. I crease it. And then we'll have a nice shape here. Yeah, so that's great. So I'm gonna mark out in this the points where I want to have a reflected geometry, right? So this is a point right here, and this is a point right here. I don't want these points because first of all, this is cut off, so that's not gonna do us any good. And second of all, if I'm folding it, like this and like this, I only need this much, right, on this side to reflect this half of the shape. So that's why I've done what I did. So we're gonna draw this line to the top here, right? This point there, this point there, this point there. And we'll have 1/2 of our template. And to be honest, that's all we really need with this template, because you can actually just flip it over, use the power of symmetry to your advantage, and flip it over to get the other side when you're creating the cardstock material. So this is actually enough. Previously, I have created the other side of this main shape here, and that takes a lot of time, and it's not completely necessary. So to be efficient, because I'm on a live stream, I'm trying to think my best how to do things efficiently. We're only going to create this side and then flip it over manually to get a the proper shape on the cardstock, right? This is just printer paper. We're just transferring the templates to a different material that we're going to make the final part out of. So we zoom in a little bit. Hopefully my phone doesn't overheat again, but if it does, I apologize in advance. I have to basically bring it into my fridge and cool it down that way, and continue. So again, I apologize if this stream is interrupted. Hang in there. I will be back in like 30 seconds if it overheats. So let's create this shape. So it's gonna start here from this vertex, right? And okay, so this ruler is not long enough. I need a different ruler. This one is in metric units, which, to be honest, you learn in school, but you never use in real life if you're in the States. I was gonna use imperial units, which are great. There's a case to be made for imperial units. It's really easy to divide into twos, right? Into halves, quarters, eighths. So, and that's really nice for design because you can always take things in ratios. So there is a place in my heart for imperial units. Call me mad, but it's what the industry uses, and it's what I like to use because it makes sense to me as an American. Anyway, like centimeters, they have their place, right? It's very precise, right? It's a smaller division, so I use it for smaller features. I know you're gonna say like, you're crazy, dude, you're mixing units, but that's what I like to do. I like to mix units. It's not like this is a plane that's gonna go to Mars or anything, right? Like it's not like a Mars rover where things are like super precise and they need to be all in one unit. So we can cut this shape out and be done with that. Yeah, so this wing is going to be interesting though, because this isn't sufficient enough for a full kind of wing. That's exactly what I did. I wasn't thinking when I made this prototype. What you have to do is actually extend this outline by a little bit. And by a little bit, I mean like all the way to the center, ideally, because that makes it extremely strong. If you put a straw or spar through that and you fold it in half, that's going to be a stiff structure. If you only have this much and attach it to the end of your fuselage, it's not going to be very structurally stable, right? This might look stable to you, but it does not feel stable, especially this side. You can really tell that it's a problem. But so we're gonna have to deal with the wings separately because we don't have enough room due to the fuselage half fold here. So I don't know. I'm gonna use my cutting board, cut this out, and then deal with the wings later, which means to say like right after I cut that template out, because in this session we are aiming to create the templates. We are not trying to really go too far, because to be frank, I am almost out of tape, which means I can't do any actual building. This tape is running low. It might look like there's still a lot of layers, but it's running low. You can use up this tape really fast. So I ordered a bunch of tape off of Amazon for about like 30 bucks. It's like 24 rolls. That's enough to last you like multiple years. So to be honest, I like to stock up like that, but that's just me. But anyways, because I don't have any tape, right? I'm running low on tape. So we're just gonna try and create like nice templates today to start off of. So yeah, hopefully this goes well. Yeah, creating the parts is basically every step up until I actually start building things and attaching things together, right? So we're gonna get as far as we can without tape. All right, so I'm gonna cut this real quick. Right, so this is gonna be interesting because we don't have an edge to really align it to, so we kind of just have to eyeball this one. Because usually if we have the side of the paper, right, this is a right angle, right? So we can just align it to the side of this board and then cut it. Yeah, got a comment. I'm just gonna look at it real quick. All right, what you doing? Making a new plane? Yes, that is the plan. We are making an X-47B. It's like a flying wing, partial. So it looks like this. I actually have a prototype already done. It's just this one is really crap, and I'm trying to make a new version of it, slightly bigger, with a thinner spar so that it'll fly really nice. So we're trying to create that in this build. There's another comment. Will it have a fairing, pen cap, nose cone, or the such? It's kind of hard to say what a fairing is for the X-47 because the whole thing is really smooth, and you know, if you look at this is like there's really no fairing anywhere. This is like an engine intake, right, an inlet, but it's like it's really smooth, and overall I don't think there's like a place for a fairing. Usually fairings are attached to places where like there's a junction. So this is Rapid Prototype 004. I was actually planning on adding a fairing to this to smooth it out and make it look more integrated with the aircraft, but it turns out tape does the same exact job and it gets the job done. It's really actually quite sturdy when you look at it. So I ended up not building a fairing for this, but I have designed fairings. If you look at if you go to Google and search University of Illinois DEP project aerospace engineering, you might see a plane that has this obvious orange nose cone. That is a fairing that I actually designed, but that's like on a different scale. That's not for paper airplanes. That's for like a university research project, which is it's distributed electric propulsion. You can probably open a tab right now and search it. But yeah, fairings at this scale, I'm not sure if they do any, like, not too much good. They add some weight. They probably do reduce drag, but at such a low Reynolds number, it's like negligible, right? A lot of these effects are negligible. And to be honest, you know, like the YX10 Astra, I've been trying to get a leading edge slat system to work, and it does. The mechanical engineering behind it is working. It works great, actually. I can show you real quick, but I do want to continue with this build. But it's like there's really no point to it. There's no purpose behind it because at this small scale, slats don't really do much, right? Control surfaces, they're still needed. They still do things, but on things like slats, it's like, do you really need it? No. But is it cool? Yes. That's why I built it. So let me actually show you real quick. I know we get like distracted often in these streams, but this is the prototype that I have right now, right? You have your canards. This is the YX10 Mark 1, or the original is the 0 Mark 0. So this is, it has your typical canard actuation mechanism. And then on the bottom here is the new slat actuation mechanism, which I think is really neat. Basically, you push this center rod here on the bottom, and it actuates this little pin here, which pushes on this rod as linked to these slats. So because of pretension, it wants to curve down, right? It wants to fold down. But if you force it to go back up, you have your retracted state for your leading edge slats. So if you pull it back, you're going to deploy the slats, right? And that's kind of just how it works by design. To my knowledge, this doesn't exist out there yet. Nobody's copied this yet, but it's a really interesting, cool experiment. And to be honest, at this scale, I don't know if it does anything for the performance. So that's why I'm doing it, just to test and have fun, I guess. I think it's really neat to have these little mechanical bits in your aircraft, because other than flying well, what's really cool about aircraft, all the moving parts. It's a machine in the end, and what gives it life is not only the way it flies, but also the way it moves and does things. So this is a prototype, work in progress. Sorry to distract you on a tangent there. I actually distracted myself on a tangent. But somebody asked about fairings. Got off on a tangent about what's actually useful at this scale of hobby gliders, or whatever you're gonna call it. And my point is, well, it's definitely not gonna do any good for the most part. It's not gonna be worth it, but I think it's so cool to play around and experiment with ideas, right? That's kind of like art and design in a nutshell. Sometimes you don't do it for the purpose, you just do it just because you can, right? And always strive for excellence like that. But anyway, we're gonna cut out this edge and this edge. Sorry for getting so sidetracked. We lost probably a couple minutes of time just going there. All right, so we lined it with the wire. Make sure it doesn't slip. And you slice it up until that point, right? The midpoint of that little cutting piece. And then this, I actually think I'm gonna use scissors, because this is a very sharp corner. If I use the cutting board, I might cut into the wing, accidentally, or cut into this area right here. That's actually more likely. So I'm gonna use scissors to cut this. All right, so that's gonna be real quick here. All right, we have our template for the main fuselage. That's great. So, yeah, that's that. We're gonna work on the wing next. This is gonna be interesting. Looks like we are almost out of paper. I'm not sure if I can fold this in half. Can I fold this in half on this? Yes, it looks like I can flip this over and still have enough space. All right, that looks like a plan. All right, so essentially I'm gonna transfer this onto this paper. This is a nice thing about printed paper, is if you get an appropriate weight, right, a super lightweight paper, you can actually see through. If you draw like a dark line, you can actually see through a paper and trace things. It's not quite tracing paper. You could definitely get tracing paper, but I have printed paper because it's cheap and it's readily available. Right. So we're just marking the vertices again. So this is a point and this is also a point, but we're actually gonna just use those for reference. So if we draw a line here, that's where the wing outboard panel starts, but we actually want it to go pretty far, right? So like somewhere here, as long as we can maintain symmetry, right? Because we want it to have some cantilever like embedded inside the fuselage to make it strong, right? You don't want it to be like this, right? So something like this. You don't want it to be like this. You want it to be like this, and so it's like very stiff and resilient when it crashes. All right, so we have that shape. You know, why don't we just cut this out anyway? Because we're about to do that anyway for this. So let's do that. All right, so got our cutting board. Yeah, so this is gonna be difficult because none of the edges align with the side of the cutter. So we're just gonna have to eyeball this. Right, then here. It is very important not to get any parallax effect, which is when, you know, because the wire is a little bit higher off the paper, right? So if you look at it from an angle, you're gonna align it incorrectly. So you gotta try and look straight on from the top. And that's just, you know, a workmanship detail that you might not think about, but it really does affect the end product. So we're gonna cut this, and cut this edge, right? Right, this is, I'm not left-handed, so this is like kind of nerve-wracking for me. All right, looks pretty good. All right, separate that piece, take away the parts that we don't need, and then make this final cut here. All right, so this is gonna be hard because the handle for this thing is blocking access to the part that I need to cut. So let's try the other way here. This is a little better. An alternative would be just to use scissors, but since I want to make really clean, really straight cuts, I'm using this cutting board. I've had this board for like probably 6 or 7 years now, so that's neat. Sorry, that's my computer, my work computer. So. All right, so we have our wing panel here. This is not very useful as a template, but we need to make the other template where we flip this over and get a decent amount of distance, right? So how far do we want it? Ideally, we would have it go to the center. So let's actually measure that. Or let's draw a line for the center line of this aircraft, right? The aircraft center is going to be from this vertex down here. And we want to extend this all the way to the middle. So I'm going to measure using inches because I like inches. You can dislike if you want. All right, I apologize for that again. The phone overheated again, so that's gonna become like a meme at this point. It's just, I can't prevent that from happening. So can you make RC, or can you make planes this size RC? It'll be kind of hard, right? So at this scale, the challenge for these planes is mostly in the propulsion. You won't get like an effective propulsion system. You might see solutions out there like Power Up, but those are for pretty lightweight, foldable, you know, a single sheet of paper, foldable designs for paper airplanes. So You can definitely experiment, but I have not seen anybody make RC planes this size. RC planes, do I work with them? I have designed one RC plane in my time in college. You can go back and on my channel and visit that video. It's called HYX01 Icarus. It was my first attempt at an RC plane design. It flew. It didn't fly great, but it flew. So, I think that's a pretty good win for a first RC plane. The plan is definitely to go in that direction because that seems like the next logical progression in this hobby. But right now, I live in an apartment and I don't really have access to all the tools I would like in order to build my RC plane designs. So I definitely have ideas in mind for RC planes. It's just it's not the right time right now for me. And it's a huge, you have to invest in a lot of tools for that. Like for example, I really like to use foam. And so you need like sanding tools, right? You need like a drill to machine wood. You need like a sander. You need saws and everything like that. And I don't have that in my apartment right now. So unfortunately, it might be a year or two or three before I get my own, like a condo or a house, hopefully. But once I do settle a little bit more permanently, I think I will, start investing in the tools that I need to really create great RC planes. That is the end goal. Don't get me wrong. I do want to go in that direction. It's just right now, at the moment, I don't have the capital to really dive into that. And I want to create great RC planes. I mean, not to say that you can't create great RC planes in an apartment, but to do what I want to do, I think I will need some more time to set that up. And that's, I need a better living space, bigger living space, with like ideally a garage or something. That way I can actually work in the garage instead of indoors and whatnot. So it's in the works, it'll take some time. Gotta save up for a house and things like that. So yeah, it's in the works. So in the meantime, I'm just doing these projects as best as I can. The spirit of what I do is not like limited to just this or RC planes. It's wanting to create something great, right? That's the end goal of what I want to do here on this channel. Just create great things. Because if you look out there right now, right, in the world, there's a lot of crazy shit happening, right? Sorry to say that, but I designated this stream as not meant for kids, and it is not meant for kids. There's a lot of crazy shit happening out there. So if I can create something great and share it online and make someone happy on the other end of the internet, then my goal is achieved, right? I feel a sense of satisfaction when I create something that's great, right, by my standards, which is slowly inflating, right? You always have to try and aim to create something better. And that's just me getting philosophical and preachy a little. So I apologize for that, but it's really what I believe in. So we're gonna get going here. Kevin A asks, how do you eliminate circumferential hub distortion on an engine? I'm trying to understand this question. On an engine inlet this size, please help. So I'm assuming you're referring to this. So I'm trying to break down that question. Eliminate circumferential hub distortion. What do you mean by the hub, right? Distortion on an inlet. I'm not quite sure I understand. If you could clarify, I would like to answer that question. But this is a straight inlet, if that's what you're asking. It's not very curved. Um, there's a straw structure on the inside that gives it a lip shape. But yeah, I'm sorry, I don't really understand that question. So if you can clarify, I would like to get back to that question. Um, sure. So let's see. This doesn't seem like enough, to be honest. Let's just start with a clean sheet of paper. This is kind of wasteful. I like to use as much of one sheet of paper as possible before I move on to another sheet of paper, but in this case it looks to be necessary. So right now I have this marked out as 5.5 inches from this vertex, at the wingtip to the center line. So we're gonna try and extend that, right? Create an extension here. That's 5.5 inches. And we can't do it this way. We actually have to do it on the bottom because we want it to be able to fold, right? So we want it to be able to fold like that on itself so that we have two layers. Yeah, just aligning this right now to the bottom edge. That's gonna save us some cutting time, machining time, basically. And we are just going to mark that and trace this out. Then also this edge right here. And then we are going to try and get 5.5 inches from this vertex right here. Okay, that's very interesting. This leading edge is not parallel. So whoever made these drawings didn't really do it accurately. That's a shame. But we're gonna have to go with it because we want it to match what we have. I don't really want to rework the templates. Yeah, there we go. And then I'm gonna mark this several times just to get like a parallel idea of a parallel line here. Right, so this is probably not parallel, but we can check by doing this. Line it up. Right. Seems pretty good. Maybe a little bit more out. Yeah, there we go. Alright, so this is one of the wings. So we're gonna cut this, and then this, and then this, and then fold it over on itself. These cuts seem pretty small, so I'm gonna use my scissors. Right, so you just cut that and remove this bit right here. Right, to create that shape. And then I'm gonna cut this here. And then this is gonna create the leading edge of that wing, which we will now fold. Oh god, it's starting to get sticky because of the summer heat and humidity, so I apologize for that. Yeah, just put like an ruler underneath. Have this right up against the edge. Right, take your time to align it. then just fold it along that edge, right? Just like pinch it so that it's a very straight fold. And all right, so now we're gonna fold that over. I'm gonna fold it flat, and we're gonna trace the other side here. Well, we could cut at this point to save time, but that's not gonna be great because your paper is like just not constrained at all, right? So I'm just tracing the end here, so just for your information. It looks like a little bit of the tip is hanging off, but that shouldn't matter too much. It's not great, it's not ideal, but in an ideal world, this line would be parallel to this edge and we wouldn't have that problem. But whoever made these drawings made it shit, so we're gonna have to deal with that. So anyway, we have to cut this, and this, and then this edge. So to do that, I'm gonna bring out the cutting board just to save us a little time. All right, so this is gonna be a cut, right? Just gotta align it with the line we want to cut. And then just slide this up until this point. And it's all good. And the rest of the cuts are gonna be pretty minor. So we can actually just do that fairly easily here. Try and keep it straight. And then here, missed a little bit. Make that cut. We'll be all set with this wing. Also, all right, so we actually have all the templates that we need, believe it or not. We just have to transfer these onto actual cardstock pieces, and that entails getting a piece of cardstock and then just putting this on, tracing the shape, and then flipping it around, tracing that shape, putting this on twice, right, to get 2 wings, and then we should be all set, pretty much. So I'm gonna do that right now. All right, so it looks like we might not have enough space for this. That's actually quite disappointing. I think I might have made it a little too big. Let's see if this works. Yeah, no, that's not gonna work. All right, so next best thing, right? What can we do? If we flip this over, we can get a majority of it in, but there's gonna be that tip cut off, which I guess we'll have to just accept, unfortunately, because there's no way around that. You could either reduce the size of your entire design, which means starting from 0, starting it all over again, or we can just use that as a feature, because actually, you know, that tip, because it folds back in here, this is like where the engine nozzle is, so it might actually work to our advantage, but definitely unintentional. So Let's mark the midpoint of this. It's gonna be 5.5 inches. Yep, 5.5, and then 5.5 down here. Because this is 11 inches, so 5.5 is exactly down the middle. Just have to connect the dots here. All right, that's our center line. Now we just have to align this as best as we can. So doing it either way shouldn't change much, but we want to maximize the amount of cardstock that we can use after creating this piece. So we're gonna align it with the tip here. Alright, so oh shoot, alright, I shifted it a little bit. Alright, align it back. Align the tip. Make sure it's aligned. Right. And just lightly use your pencil. Apologize for that. Use your pencil to trace out that shape. So you have to be very careful because you can damage the template. This is like not a very so you're just transferring the printer template to a stiffer material. In my early days of this, I actually just used the printer paper as the actual part. So you'll notice most of my early planes have been white in color, but that has changed because I decided it's better to make parts using cardstock. It's more durable, and these planes last a lot longer. They fly better too because of the extra weight, which gives it momentum in flight. So by switching materials, that made me relook at the process behind making these parts. So that's why I'm doing it this way nowadays. I'll probably just draw that manually, but let's keep this the same where it was at. Okay, just trace this. Trace this. Trace this in, right? And so we have one side, right, with that truncated bit because we didn't plan for that, but it is what it is. Then do the same here. We align that together. And then just trace that out. Okay, so these two pieces don't exactly match for some reason, but alright, shift this a little bit to make it match. Right, like that, like that, like that. Ongoing. Alright, so I left off at the template I was creating here. I'm just gonna trace the rest of this. I'll zoom in a little bit. And I think I got most of it, actually. Yeah, I do have all of it. So we're all set there. We have the template now. And now we're gonna try and create the main wings here. All right, so this is what I'm planning on doing for the wing outboard panels that are going to stretch all the way into the middle. To save material, to save another sheet of cardstock, I am going to fit this piece into this area right here. What that means is we're going to have to truncate this bottom triangle, right? We're going to have to get rid of that because we don't have enough paper. We don't have enough cardstock material underneath that. I'm going to have to get rid of this left side here. That should be okay because this is on the inboard. So this is going to be inside the fuselage, right? So it's okay to have a little bit of missing material, right? I want to be economical and I guess really just be efficient with material. So we're making these slight changes to accommodate that. So we're going to trace the rest of this template, right? You notice, like, I chose to sacrifice a bit of the material on the inside, right? Because that's going to be on the inside. It's not going to be where you see it. But on the outside of the wing panel, we're still having, like, the proper shape here, right? So that's an important thing to note. Right, there we go. Just trace this one edge down here, way up, and we're all set there. So cut this shape out, right, this massive shape out, and then we're going to trace it again on this side. We'll keep it identical as close as we can to what we had on the other side. Right, so it's not perfect geometry, but if you were to achieve perfect geometry, you would have to sacrifice more material, right? And I want to be conscious of that because you could use a ton of material and get the job done, but it's not being efficient and you're wasting a lot of cardstock. So I'm just going to trace this shape out on this side. Right, and that should be aligned with that edge. So they share an edge, which is a double-sided blade, basically. Because what that means is if you make an error on that cut, you're gonna make an error on two parts. But luckily, I do have a cutting board, so the chance of that happening is low. Right. Great. I have every edge I need. Great. So we traced the templates. These are the two templates that you need to trace down your parts. So now I have my parts marked down. I think the rest of the stream today, I'm probably just gonna cut this out since I do have some tape. I'm not sure if I want to continue too much though. We'll see. We'll see where we get. Right now, let's just take our cutting board and try and cut this cardstock to spec, right, to the shapes that we drew. Right, so from left to right, it's gonna be kind of tricky because it's gray and pencil marking is gray. That should be good. Right? That's a very clean, minimal cut. Move that back, reset it. Move this down. Match this. Vertex. There we go. All right, so it looks like we missed a little bit off the tip. Chopped a little bit, but for the most part, it should be good. So, that's the thing with a cutting board is it's really good cuts, but just aligning it, if you make a small mistake, and it's not gonna be really great for the end result. Okay, so that's quick, clean, gets the job done. All right, that's aligned. And we have that cut. Great. Now comes the fun bit. This is where I think we'll have to start using scissors. Simply because we don't have enough space to use the cutting board. So we'll keep these scraps. We might be able to use them later, but for these sections here, so essentially we want to cut out this area right here, right? It goes through here, that little channel, and we also want to cut out that. So we're just lightly marking where we want to cut. Just zoom in a little bit and start cutting away. Right, trim that little edge there, and then cut in here. And make this cut right here. Right, so my strategy is to do whatever is easiest first. That way we have a lot more possibilities when it comes to the difficult bits. Right. So I'm gonna make this cut right here. All right, so we can separate that piece just to reduce the amount of material hanging off of our workpiece. That's not perfect. Damn. Alright, so we're just trimming that. Making sure that's good. Alright, so actually I think this edge will have to be done with a cutter, but we still need to eliminate this little triangle here. And I don't think my scissors are going to really do the job here. So we're gonna rely on X-Acto knives. The reason why I didn't use this earlier is that for these long cuts, it's easier to use a cutting board. But for these short, edges here, that's easy to do with a pair of scissors. So we're gonna do that. But for these, it's really hard to turn your scissors once you get into that corner, right? So it's actually easier to just use X-Acto knives to cut directly, and I think I mentioned that in my last stream as well. But yeah, this is just kind of a repeat of that. I'm just gonna make a solid straight cut down. Right. This is a cutting mat, self-healing. It doesn't actually heal itself, it just compresses the cut so that you don't really feel it. So it does get damaged, but it doesn't really show it that much. Alright, so right now I'm tilting this so that I don't get a shadow on the line that I'm trying to cut. Just gonna freehand this last bit here. Alright, so just want to double check that I made that cut through. Yep. There we go. Now for sure, the cut is there. Alright, I'm gonna do the same for this vertex all the way to here. Great. And then this edge will be cut later. Let's make these cuts here on the other side. Right. That's that. Alright, so I'm gonna cut this from in to out. Alright, it's a clean cut. And then straight cut all the way here, scissor cut here, scissor, scissor, scissor. Alright, so we are all set. I just need to use scissors here. Well, we could use an X-Acto, but I would like to minimize the amount of damage that I do to the mat. I mean, like, you could say, like, it's a cutting mat, it's meant for cutting, but I still want to try and protect this to keep being able to use it as long as I can. So great. All right, now we can, actually for this cut, I think instead of scissors, I might use my X-Acto, just because it needs to be a pretty straight cut, otherwise the error is on both pieces. All right, there we go. All right, pretty clean cut. So it's not, it didn't quite cut through. Might need to, shit. This is why you always use a straight edge. Alright, sometimes it takes 2 cuts to make it clean. Alright, and then these 2 cuts are going to be the cutting board, straight edge cutter thing. Like, this is like boring. This is the most boring part about making, just getting the right shapes. but once you get into the zone, you can like really create something great. It's like hard to get started with these things. Shit, I cut into the other wing a little bit. I wasn't paying attention. All right. Well, the good thing is I don't have to pay attention now because there's nothing here to cut into. That's unfortunate. I don't think it should matter because it's on the inside anyway. All right. Get rid of those straps. So we have one perfect wing here, I think. Yep. I just need to trim this a little bit. Wait a minute. Yeah, okay, so let's actually figure out what just happened. Alright. We have this, right? This is our piece of paper. We accidentally cut a little bit in, but for the most part, it should be okay. Right, let's see what the template was. The template was like this. So, right, okay, the template was truncated, so it's asymmetric, which makes sense because now it's asymmetric. Sorry, I confused myself a little bit. But yeah, this little triangle down here doesn't exist, so. Alright. As long as we fold it in half and align these features right here, we should get our main wing. So. I'll just clean up this fuselage piece here. Done. Just had to pull that little piece off. Alright, just gonna draw a line real quick just to finish this off. Great. Alright, so now this is pretty much there. The thing is, we might need another one of these pieces. Because this serves as a base, and once you make your wings, you put this in, you fold it over, but then once you fold it over, you might need additional pieces to like, okay, actually maybe you only need one piece to keep things light. All right, cool. We'll just keep it like it is then. This is a careless mistake. I did that on accident, so don't be like me. Try not to make these mistakes. I got a little too carried away with cutting, so that's that. Yeah, so for the rest of today, I feel like what I should do is just kind of mark this down, or we could, instead of marking it, we could actually just fold it, and then mount the spars and stuff, so that's not too tape intensive. I want to try and get this stream to about 2 hours, so we have approximately 20 more minutes. Yeah, that sounds like a plan. Let's do that. So here, what I'm gonna do is just fold this in on itself. This is maybe not the best way to do this. Yeah. But anyways, we're live again. Just gonna fold the main wings here today. Alright. So yeah, that's really frustrating. that my phone overheated. All right. So we're just gonna mark where it's supposed to end. Right. Just gonna mark that. Yeah, apologies for that. Phone overheated again for like the 4th or 5th time already today, which is really unacceptable, but I have to live with that. I'll just draw the middle line there. I'm gonna do the same here for this one. We're gonna take our template, match it up real nice. Right. So match it up on this side. All right, just making sure. And then here, where this center line is, make a line there. And you just kind of trace from this vertex down the middle. That was crap, yeah. Sorry guys, it's really warm today. Getting kind of tired. So let's try that again. There we go, that's a much better line. All right. So now that we have those lines marked out, we can create the folds, which again, is very similar to what we've done before. Just align the edge, one ruler, and then use the other ruler to pinch, right, to create a really straight edge. And that's that. And then for the other one here, just zoom out a little bit. It's the same idea. Line it up with that edge. Line it up with this edge. Vertex, and then just fold this, pinch it, fold. All right, so now we have our wing assembly, or main wing surface, right? Or the, the outboard wing surface. So these bits here are not perfect, right? But it's what happens when you want to try and be economical with the materials that you're using. So this will fit in right about here. Right. So we need to mount our spars, right? And then just make the wings, and then just close the entire thing down. Right. So this is interesting. It's asymmetric. Oh, I think it shouldn't matter too much, to be honest. But all right, so yeah. 15 more minutes. Let's try mounting the. All right, let's sort out this geometry problem, right? So this is a problem because I didn't plan ahead. So this is a mistake again. This side, I think I'm gonna reverse this edge. Yeah. All right, yeah, and I'm going to erase, use an eraser to lightly remove some of these construction lines. All right, and now we have matching parts. There we go, much better. All right, so for the spar of this plane, I want it to be thin to get better performance, and I want it to be strong. So we're gonna go with the same material that I used for Rapid Prototype 004, which are popsicle sticks. Now these come in boxes of about 1,000. They're about $7 each box, so highly worth it in my opinion if you build things a lot. It's just a great deal. It's renewable resources, so we have our main fuselage here, right? It's a flying wing, so it's like a wing body part. Align this edge to the middle, right? And then I want to just tape this in place, to be honest, but we want to be accurate, right? So I think I'm gonna mount the spar right about here, and the reason for that is this creates a nice little area here. It's like this distance is kind of constant around here, right? It's like kind of tangent here, but we'll have to figure out how to really define that location so that we can replicate it on the other side. But yeah, this is generally where I want it to be. You can measure like how far off this is. This looks like it's about half a centimeter. Oh, okay, it's 0.6. Let's see imperial units, how that measures out. Apologize for that. It's about 1/4 of an inch. Wow, I am really good at eyeballing. All right, so 1/4 of an inch, and then I want to go a little bit more. No, let's just constrain it to here. Like if you have a perpendicular edge, right, to the leading edge, you drop back 1/4 of an inch wherever this popsicle stick meets. So this is where some design decisions get made, right? And you just have to be mindful of what you do. You can also measure on the other side, right? As long as these two sticks are not different lengths, it should be good. They're pretty much the same length, which is a good thing. That's a plus. All right, so all right, so we're gonna mark out 1/4 of an inch. Right, and 1/4 of an inch here. Yep. And then just connect these. This is the line on which we want to mount our spar. 2 points determine a line. That is a geometric fact. I don't say school is not useless. Or don't say school is useless. There we go. Right, school teaches you many important things. Geometry might be boring, but it can help you build planes. There we go. Quarter inch here. Right. And then 1/4 of an inch here. And it really doesn't matter where you make that 1/4 of an inch mark, as long as there's 2 points. Draw a line that's parallel to the leading edge. That's how I want to mount the spars. So now we have to decide how to, like, where along this to mount the spar, right? Like where. So this is where I'm going to just constrain it like this, right? I'm using the mark on the 10 here to act as a square. So as long as that's in line with the leading edge fold here, that means I should be all set. Right? And I want it to be so that the circle, tip of the circle end of this popsicle stick reaches this ruler. Just barely touches it. Great. All right, so now that we have it fixed in place, we can now apply tape. Now I said I wouldn't use tape in this build, but I have a little bit of tape left. Not a lot. That's why I don't want to do like any major assembling. But for small, things like this, it's still doable. So I'm just gonna really secure that in place. Right. And then make sure it's kind of parallel. All right, fix that, and I'll just fold that down. Fold that in. Fold that in. Should be all set there. And we have one wing. This is a thinner wing than before. It's very strong and it's very durable. So this is one side done. I just have to do the same thing to the other side. We already marked out the 1/4 inch line off the leading edge. Now we just need to determine where, right, again, where along that line to mount the spar. And again, that's going to be perpendicular off this edge right here. Right. And then just mount it like that. Line up that edge. And then constrain it to the ruler. All right, so now pinching it in place. All right. Get that vertical action there on the side of the popsicle stick. All right, and then we have that secured. I'll just do the inboard here. It's the exact same idea. All right. And I think for both of these, we want to secure it again in the middle to prevent flexing. So like if it's not like attached properly, you know, you can have some play, right, where you can have a gap in the middle. So just to be safe, I'm gonna apply one more in the middle here. Right. That's gonna be tight, right? Fold it over, straight over the edge. Pinch that down in place. And then do the same thing here. Right, take that down. Right. So that's all set. And now you have one wing done. You want to do the other one too, just in the middle, right? So something like that. Just fold that straight over. Fold this straight down. Just fold that in place. Crush that tape into place. Make sure that adhesive bonds with the paper. Right, and then you're all set. And now we can either finish off the wings and put them on, or put them on and then finish off the wings. I feel like I'm not sure, to be honest. Let me think about this for a quick second. I can seal each wing first. Let's do that. Right. So, I know I said I wouldn't use a lot of tape, but this is actually a decent amount of tape. I'm gonna prioritize the inboard here, because it's just more important at the moment. If the inboard isn't taped correctly, the outboard is not going to be correct either. So, but if you can secure the inboard first and constrain it, then you might get a decent outboard. So. Crush that into place. Look at that. That is beautiful. Look at that. You know, like, some people are really into knives, into EDC knives, you know, and this is like when I kind of understand them. Is like when you see a wing that's like symmetric top and bottom like this from the back, it's just beautiful, man. Like, there's thickness and there's the center line. Right, it's just beautiful, and it's pretty straight too. It's a little bit bent because I didn't secure it all the way, right? So I need a little segment of tape out here and in the front, right? But overall, I think this is a really well done wing. Now I just have to do the same for the other side. I'm gonna try and get the full length this time, right? Just kind of measure using your fingers, and then take a piece of tape. This one is pretty long. Right, take that in place, right? And just go on the other side here and do this, because if we flipped it around and did it to the tape on the other side, well, then this side, this sticky part would stick onto something, and we don't want that. So it's just thinking around potential issues, right? And here, Just gonna securely fold this around. Right, tightly wrap this around that trailing edge, right? Just, apply a decent amount of force, really crush that in, right? And then look at that. It's so beautiful. It's so thin, right? It has a slightly blunt leading edge. Right, if you look at that, it's a blunt leading edge. And then the trailing edge is super sharp, right? And that's what an airfoil is supposed to be like. So, anyways. Alright, I think we're about done for today. This is a good place to stop. We made the 2 wings, right? Might need to trim off a little bit of this geometry next time, but next time should be pretty interesting. I'll have a full supply of tape, so we'll be ready to actually install some of the centerline straws, right? Just cut this and then build the fuselage up, and then once that's done, once the wings are attached, right? So we're gonna attach the wings. We're gonna build the fuselage on top of that to really pinch the wings in place to the fuselage, and then we're gonna close it all up by folding this in, and then we'll be pretty much all set. We just need a couple more panel pieces on the top. And for this iteration, I will not be including intakes because they detract from flight performance, and I want to keep things simple and effective for flight, not for looks this time. So that's the plan going forward. I think this is a good place to stop. So that's pretty much it. If you're watching this at a later date, congratulations, you made it to the end. Yeah, just leave any comments, questions, whatever down in the comments. I'll try to respond to them. All right. I apologize again for that interruption. My phone overheated again. How fitting, right? What a great way to end this stream. But yeah, so next time I will be assembling the actual parts here, building up the fuselage, attaching the wings, closing it all up, and then surface finishing, patching any seams. So I gotta be quick here before my phone overheats again. But thanks for watching. Stay tuned. Leave any questions in the comments below, and I will try and get back to them as soon as I can. And we'll see you next Friday. So, yep, that's pretty much it. So, thanks for watching.